Okay, I got about 17 of us in right now. Let's try to get the rest of you to catch up. XQGOP. Give you another minute or so. And then while we're waiting on folks to catch up on the graph, I'm going to draw a motion map up here, if I can find a marker. Oh, man. All right, so let's see some of the examples here, my friends. All right, these are not all of the answers, but these are a couple of the different examples, okay? So there's kind of this like frowny mouth, there's a smiley mouth, there's this peaky thing, there's this kind of swoopy thing. And then for the velocity graphs, some go like that, some go like that, some go like that, some go like that. Okay, there's a lot of differences. So I need you to talk with your friends and neighbors about the position versus time graph. If the detector starts out at the bottom, the cart starts out by the detector's at the bottom. Cart's gonna go like that, okay? So when on this position versus time graph, should your position be closest to 0? Run that by your neighbor really quick. All right. So position, time graph. The detector's at the bottom. The detector is the thing that establishes 0. So when is this thing going to have a position closest to 0? So at the start and at the end. So at the start and at the end, you're going to have a position that's close to zero. Okay? Its greatest position is going to be when it's at the top of the ramp here, farthest away from the detector. That's going to happen in the middle. Now keep in mind, slope on position versus time graph is velocity. So is there any point in this motion from when it leaves my hand until it gets back to my hand? Is there any point in that motion where the velocity is either zero or close to zero? Okay, run that by your neighbor really quick. When is it going slowest? Check with your neighbor. And I will tell you this, right? The slowest velocity goes with the flattest slope. So where on this graph, if I call these points A, B, C, where on that graph, let's throw this on the pear deck, where on that graph should the slope be the flattest, A, B, or C? Get in, get in, get in. All right, our friends are saying B, 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 okay? Good. So point B, the graph should be relatively flat. And then where is it fastest? Well, that's at A and C, okay? So it's got to be steep here. It's got to be steep there. That's going to mean the position time graph has to have that shape to it. Now, if that's the shape of the position versus time graph, then we can double check this quick. Let's do it. So position and time, meter stick, meter stick, meter stick. All right, space bar. Bruh. Yeah? Frowny face graph. Okay? Frowny face graph. All right. So, and you could be putting this on your note sheet that goes with the other part of it or whatever, okay? So now if we're going to draw the velocity versus time graph, if that's the position graph, and velocity value is the slope of the position versus time graph, are there any points where the slope on this graph is zero? That coincides with the velocity zero. So kind of build your graph out that way. Are there any points on this graph where the velocity is positive? Are there any points on this graph where the velocity is negative? Go ahead and sketch that out on your sheet a little bit. Or yeah, you can change it in your pear deck too. Lo siento. I'll back up to your graph. There's your graph. Give me a chance. It's my first day. So if that's the position versus time graph, and if velocity is the slope on the position versus time graph, Try to identify where's the slope the greatest, where's the slope the least. Is the slope ever 0? And some of you are directing some anger at the Chromebooks. Be well, friends. It's going to be okay. So I think I need to ask you this question. Is there ever a spot on this position graph where the slope is 0? Okay, let me ask you on the Pear Deck. So is slope ever 0? Is the slope ever 0? And I'm talking about the position versus time graph. Is that slope ever 0? Bro, this is science. No yes, no answers. All right, you got a little bit of B, point B, the highest point on the graph, the slope is equal to 0. B, yes, no, maybe so. When it's at B, yes, at the top, yes, it's flat at point B. This is what you're looking for. Is that graph ever flat, even for a moment? And by flat, like I'm talking horizontal. Here at E, right, I do that little segment there. It's basically flat. Visually, if you're just watching this, okay, and listening, you can tell it's going slowest at that point as well. So on your velocity versus time graph, it's going to need to go through there. Okay? So go back over to the Pear Deck and make sure on your velocity versus time graph, you're showing a velocity of 0 at that point. And then think about what the slope at A and the slope at C are telling you about the velocity at those times. So again, are you showing a velocity of 0 at that time on your velocity versus time graph? And then generally speaking, right, if we're looking at a graph, this is a positive slope. And this would be a negative slope. Okay, sloping up or sloping down. When you look at A, if you were to just break that into a little chunk right here, does that look more like the positive slope or the negative slope graph? Come on, pen. And when you look at C, does that look more like a positive or a negative slope graph? So go into your Pear Deck, okay, and make sure that your velocity is agreeing with the slope on the position graph at A, with the slope on the position graph at C. So again, I'm asking you to pop onto that graph and compare that. Look at that segment. Does that look more like this red line or this blue line? Look at that segment at C. Does that look more like the red line or the blue line? I don't think they look identical. Okay, so be mindful of that. We'll pick up with this on Monday. Have a great weekend.